Yeah, good morning students. This is Mohammed Subhani, working as an associate professor in the Department of Mechanical Engineering. Today our topic is transportation problem. So this topic is available in operations research, applied operations research and optimization technique courses also. So in that, the transportation problem, I will teach this by taking an example. So here already we have written the problem. So here we are having the S1, S2, S3 and D1, D2, D3, D4. Here S1, S2, S3 are the sources and D1, D2, D3, D4 are the demands. So that means here the 19, 30, these are the costs. So here 19 indicates that from S1 to D1, what will be the fare to transport the 7 units or unit price of that particular S1 to D1 fare, sir. So likewise the 20 indicates from S3 to D4, what will be the fare. So likewise these are the costs from S1, S2, S3 to D1, D2, D3, D4. So these are the costs given in the problem. So and also we are having the supply and demand. So that means the S1 is having a maximum supply, it can supply maximum of 7 units, the S2 is supplying a maximum of 9 units, and S3 is having the maximum supply of 18 units. Likewise, the demand for D1 is, it can accommodate only 5 units, so D2 is accommodating 8, so D3 is accommodating 7 units, and D4 is accommodating 14 units. So now, by using these transportation techniques, we have to find out the minimum transportation cost, and then it has to satisfy all the S1, S2, S3s, has to be transported to all the destinations, that is D1, D2, D3, D4. So for that, the transportation problem, the step 1, we are having the step-by-step procedure. So for that, the step 1 is whether the condition is in the maximum or minimum we have to look after. So only if the condition is in the minimum, then only it will be possible to do the transportation problem. Why? Because here we have to calculate the minimum transportation cost. So if the problem is given, already this problem is given in the minimization, so no need to convert this into the other problem. So if the problem is given in the maximization, we have to convert the problem into the minimization problem. So how we can convert the problem into minimization problem means, so you have to take the highest cost. So here the highest cost is 70. So from that 70 we have to subtract from all the cost, then automatically that maximization problem will be converted into the minimization problem. So already, so we have the first step is we have to look after the condition should be minimum, and the second one is the transportation problem should be balanced problem. Balanced means the supply and demand should be equal. So here in this problem we are having supply as 7, 9, 18. So if you add these 3, 7 plus 9, 16 plus 18, that means we'll get 34. So likewise the demand, 5 plus 8, 13, 13 plus 7, 20, 20 plus 14, it will also have 34. So we have to check the condition whether the supply and demand are equal or not. So that is we call as a balanced problem. So only if the problem is balanced, then only we can go further. The first step is we have to check for the minimum condition, and the second one is we have to check for the balanced or unbalanced problem. If the unbalanced problem is given, so that means here in the place of 14, the 12 is given. So it is having a lagging of some 2 units. So then we have to add one dummy column, like D5. Here we can write 0, 0, 0, and here we can write 2. So by this procedure we can balance that problem. And the third one is we have to calculate the IBFS. IBFS is nothing but initial basic feasible solution. Initial basic feasible solution. So to do this initial basic feasible solution, we are having 3 methods. The first one is northwest corner method, second one is least cost method, and the third one is Vogel's approximation method. So this method is also called as a penalty method also. So to calculate, to do the problem in IBFS, that is initial basic solution for this transportation problem, we are having 3 methods. So that is the first one is northwest corner method, the second one is least cost method, the third one is Vogel's approximation method. Vogel's approximation method is also called as a penalty method also. So after getting IBFS from these 3, so we can perform any one IBFS, sir. So after that, the next step is we have to check for the degeneracy. Degeneracy means number of allocated cells must be less than or equals to the m plus n minus 1. There m is the number of rows and n is the number of columns. So this will be discussed later. And then after degeneracy, we are having the optimality test. So for optimal test, we are having Modi method, stepping stone method. So for optimal test, we are having 2 methods. The first method is Modi method, and the second method is stepping stone method. So today in this lecture, I will discuss about the IBFS, these 3 methods, and the next lecture we will discuss about the optimality test also. Now this problem, now I will calculate by using the northwest corner method. So by using the northwest corner method, I will solve this problem. The first IBFS. So first of all, in northwest corner method, so first of all we have to identify the cells. So here we are having some fourth is 12 cells. So in that the first cell is S1 D1 cell, that 19 indicates the S1 D1 cell, and this 30 indicates S1 D2 cell, and this 50 indicates the S1 D3 cell. So likewise we are having some 12 cells. So in northwest corner method, we have to identify the northwest cell in this particular matrix. So in that the northwest is nothing but the left side top corner. So the left side top corner of this one is 19. So here we can allocate. So first of all, by using this one, so we have to allocate the supplies. Here we are having 7 supply for S1 and 5 is the demand for D1. So here we are having 5. The D1 capacity is 5 units. S1 capacity is 7 units. So in 19 we can accommodate only 5 units. So if you accommodate 5 units over here, already the D1 will be satisfied. So here only the 2 will be the remaining balance. Why? Because already the 5 is allocated over here. So here 19, how we selected the 19 means it is the northwest corner of that particular given matrix. Okay. So next, so after that already the D1 is satisfied, right? Here the D1 is satisfied. So that's why, so we can eliminate these complete D1 rows. Why? Because already the D1 is satisfied. We are having no units left over here. So only the S1 is having the 2 units left over here. And then we have to accommodate another table. So I am preparing another table. So in that table I am removing the D1. Only I am writing S1, S2, S3. So now I am removing the D1. Only I am writing D2, D3, D4. D2, D3, D4. Why? Because the D1 is already satisfied. So the 5 units are already allocated at 19, that S1 D1 cell. So after that the D2, D3, D4 values we are having as 30, 50, 10, 30, 40, 60, 8, 70 and 20. So now the supply for the S1, the remaining supply is only, so this is the second table, this is the table 2 and here this is one, we'll call it as a table 1. So in table 2 we are eliminating the D1. Why? Because it is satisfied. So here the S1, the balance for the supply S1 is only 2 and 9 and then 18. So for D2, D3, D4 we are having 8, 7 and 14. So now in this matrix also we have to find out the northwest cell. So northwest cell. So in this the northwest cell is this D2, S1 D2. So here how much we can allocate? Here we are having the D2 capacity as 8 and S1 is capacity as 2. So here we can accommodate only 2. So if you accommodate 2 over here the balance will be 6 and here it is 0. So already the S1 will be satisfied. So then we can remove this S1 also. So now we can frame the table 3. So in that table 3 we are having only S2, S3 and D2, D3, D4. So I am framing the table for that one. S2, S3 and also D2, D3 and D4. The values are in table 3. In table 3, already in the table 2, this S1 is already satisfied. So in table 3, we are having only S2 and S3 and D2, D3, D4. So I am writing the values that 30, 40, 60, 8, 70 and 20. The supply values are 9 and 18. So here we are having 6, 7 and 14. So in that the northwest corner cell is this S2, D2. So how much we can accommodate over here? So we can accommodate, here we are having 6 units, here we are having 9 units. So here we can accommodate 6 units. So if you accommodate 6 over here it will be 0 and here we are having only 3 units left over here. So already it is 0 means we can eliminate this D2. So after that we have to frame the table 4 also. In table 4 already the D2 is satisfied. So we will get the 2 by 2 matrix, that is S2, S3 and D3, D4. This is S2, S3, D3, D4. So the values are 40, 60, 70 and 20. Here we are having 3, 18, 7, 14. So now we have to identify the northwest corner. So in this the northwest corner cell is 40. So here we can accommodate. So here we are having 3 and here we are having 7. So we can accommodate only 3 units in the S2 D3 cell. Here we will get 4 and here we will get 0. That means the S2 will be satisfied. Only the leftover is S3, D3, D4. So for that we have to frame the on the table 5. So here S3. So here we are having D3 and D4. We are having 70 and 20. Here we are having 18. Here we are having 4 and 14. So in this the northwest cell is 70. Northwest cell is 70. Here we can accommodate 4. So this will be satisfied. And here only the 14 left. So here we are having 14. We can accommodate directly. We can accommodate 14 over here. So that means everything will be satisfied. So now I have to frame the each and every whatever the allocations we are having, we have to allocate over here. So here in this first table itself only I am allocating. Already in 19 we are having 5. So after in the table 2, S1 D2. S1 D2 is nothing but this one. So here we are having we are allocated 2. We are allocated 2 over here. So in third table, we have allocated at S2 D2 the 6 units, the S2 D2, that means here the 6 units. And then in table 4, we have allocated at S2 D3 the 3 units, S2 D3 the 3 units. And then in table 5, we have allocated at S3 D3 and S3 D4. S3 D3 here we are allocated 4, and here we have allocated 14 units. So in Northwest car method, till now we have allocated the cells, and we have satisfied all the supplies and demands like this. So now we have to calculate the transportation cost. So this 19 indicates the unit cost from S1 to D1. So now this 5 indicates the how much units we have allocated for S1 to D1. So likewise, the 30 indicates the unit cost from S1 to D2. The 2 indicates the from S1 we have allocated 2 units to D2, like that. So like that we are having some 6 allocations out of these 12 cells. So now we have to calculate that cost, IBFS, that initial basic feasible solution. That is the transportation cost we have to calculate. So we have to calculate the transportation cost by multiplying these two, 19 into 5. So the unit cost is 19, and we have allocated the 5 units, plus this 30 into 2, plus this 30 into 6, plus this 40 into 3, plus this 70 into 4, this is 70, plus 20 into 14. So finally, if you multiply this one, we will get the value as 1015 rupees. So 1015 rupees we are getting if you do this problem in Northwest corner method. So same problem I will do it by using the least cost method also. So remember this value. Okay, at last we will tell what is the differences between these 3 methods also. So now I am going with the least cost method, the second IBFS method. So for the same problem I am calculating for the least cost method. So in the least cost method, first of all we have to identify the least cost or the total. So here this is the supply S1, S2, S3, D1, D2. So already we will know about this S1, S2, S3 and D1, D2, D3, D4. So out of this cost, which is the minimum cost? So here 19, 30, 50, out of this the 7 is the minimum cost. So first of all we have to select the minimum cost, and then in that cell we have to allocate. So in that cell already we are having 7 over here, here we are having 18. So how much we can accommodate over here? We can allocate 7 over here. If you allocate 7, it will be 0, and here we will get 11. So already it is 0 means we can eliminate this D3. Is it or not? So and then, so after eliminating the D3, the rest of the cost, what is the least cost over here? So rest of the members, the least cost will be 8. So here we can accommodate. So here we can accommodate, here we are having 8 for D2, and for S3 we are having the leftover is 11 units. So here we can accommodate 8. So if you accommodate 8 over here, you will get 0 over here, and here we will get 3. So here we are getting 0 means we can eliminate this D2 also. So out of the rest costs, which is the minimum cost? The 10. So we can accommodate over 10. So 10 we are having 7 over here and 14 over here. So here we can accommodate only 7 units. If you accommodate 7 units over here, we will get 7, and here we will get 7. So already we can eliminate this 19 also. And then the leftover parts are 70, 60, 40, 14. So in that the minimum cost will be 14. Okay. So here we can accommodate, here we are having 7 and 3. So here we can accommodate only 3. So here we will get 4, and here we will get 0. So already this S3 will be satisfied. So that's why we can eliminate this 40 also. So now the leftover is 70 and 60. So in 70 and 60, the minimum cost is 60. Okay. So here we can accommodate 4. So if you accommodate 4, the balance will be 0. Here the balance will be 5. So already it is 0 means we can accommodate the D4 is satisfied. So the leftover is 70. Here we can accommodate 5. We will get 0, and we will get 0 over here. So this is the allocations we have getting by using this least cost method. So if you want to calculate the transportation cost, so we can calculate the transportation cost as, so here we are getting 10 into 7 plus 70 into 5 plus 60 into 4 plus 8 into 8 plus 7 into 7 plus 14 into 3. So if you do the calculation, we will get the value as, in last cost method is 814 rupees. So in Northwest corner method we will get 1015 rupees. In this least cost method we will get 814 rupees. So this is the second method, and the third method is Vogel's approximation method. So this third method is also called as a penalty method. So I am doing with the same problem I am doing for the VAM also, Vogel's approximation method also. The Vogel's approximation method we have to calculate the penalties. So row penalty and column penalty. So the penalty is nothing but the difference between the least two numbers. The penalty is nothing but the difference between the least two numbers. For example, in S1 we are having 19, 30, 50, 10. So in this the least two numbers are 19 and 10. So what is the difference between these two, 19 and 10? 9. So likewise we have to calculate the penalties for S1, S2, S3 as well as for D1, D2, D3, D4. So if you calculate for S1, S2, S3, you will calculate as a row penalty. So if you calculate for D1, D2, D3, they will calculate as a column penalty. So here we have to calculate the row penalty. So here the least two numbers are 30 and 40. The difference is 10. So in the S3 row, we are having the least two numbers are 80 and 20. The difference will be 12. So in the D1, out of these three, the least two numbers are 40 and 19. The difference will be 21. In these two, 30 and 8, we will get 22. So out of these two, the least two numbers are 50 and 40. We will get the difference as 10. So out of these two also, we will get the. So here, till now, we have calculated the penalties, whether it may be a row penalty or column penalty. So out of these, what is the highest penalty? Where we are getting the highest penalty means this 22 will be the highest penalty. Okay, so in that row or column. So if you are getting the highest value in the row, you can select that row. Wherever you are getting the highest penalty, you have to select that row or column. So here in the D2 column, we are getting the highest penalty. So in that row or column, whatever the least cost is there, we have to select that cell. Now out of this 30, 30 and 8, the 8 is the minimum cost. So here we can accommodate how much? Here we are having 8, here we are having 18. So we can accommodate 8 easily over here, and here we will get 0, and here we will get 10. Okay, so here we are getting 0 means we can eliminate this D2. Now we have to calculate the second penalty. This is the first penalty, we will say. So now we have to calculate the second row penalty and second column penalty. So out of these three, that means 90, 50 and 10, what is the least two numbers? Least two numbers are 19 and 10. Now we will get the row penalty as 9 only. So next, after this one, 70, 40, 60. The least two numbers are 40 and 60. Now we will get the penalty as 20. Out of this 40, 70 and 20, the least numbers are 40 and 20, and we will get the penalty as 20. Out of this D1, the same 21 will be there. So we can already accommodate it. So we can leave that D2 column. So in D3, we are having 50, 40 and 70. The penalty will be 10. So here also the penalty will be 10. So now out of these 5, 21, 10, 10, 20, 29, the 21 is the highest penalty we are getting. So in that highest penalty, we have to select the least cost. In this, the least cost is 19. So in 19, how much we can accommodate? Here we are having 5, here we are having 7. So we can accommodate 5 over here. So if you accommodate 5 over here, we will left over is 0. Here only the 2 will be the balance. So if it is 0 means we can delete these 2. So after that, we have to calculate the third penalty also. Third row penalty and third column penalties. So here, so only the 2 will be left over, 50 and 10. So we will get 40. Okay, after that we are having 40 and 60, the penalty will be 20. Here we are having 70 and 20, the penalty will be 50. So here already this is satisfied and this is also satisfied. Here 50, 40, 70, we are having the penalty as 10. So here also we are having the penalty as 10. So out of these third penalties, the highest penalty is 50. So now we have to select this row. So in this row, which is the lowest cost? 20 is the lowest cost. So here we are having 14 and here we are having 10. So we can accommodate 10 over here. So the leftover is 4 over here, and here totally satisfied, 0. So already totally satisfied means we can accommodate, delete this 70 also. And then the leftover is this D3, D4 and S1, S2. So we have to calculate the another penalties also, fourth penalty. If you calculate the fourth penalties, so already this one is satisfied, this one is satisfied. So from 50 and 40 we are having the difference of 10. So here only 10 and 60, the difference will be 50. So here the difference will be 40. 40 and 60, the difference will be 20. Already this is satisfied. So out of this, the highest penalty is 50. Now we have to select this one. So in this, the lowest value is 10. Here we can have the 4 over here and 2 over here. We can accommodate 2 only. If you accommodate 2, you will get 0 over here, and you have only 2 left over here. So here we are getting 0 means can eliminate that 50 also. Why? Because the rest one is satisfied. Now the leftover cells are 40 and 60. So if you want to calculate the penalties also, no problem. Directly you can accommodate in 40 and 60. So if you accommodate in 40, here we are having 9, here we are having 7. So we can accommodate maximum of 7 over here. If you accommodate 7, the leftover is 2. Okay. So in 60, so it is 0 means we can accommodate this one. In 60, here we are having 2. Here also we are having 2. If you accommodate 2, everything will be satisfied. So this is our final table. Now we have to calculate the minimum transportation cost. That is transportation cost. So your transportation cost equals to 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. So finally we'll get the value as, so in this method we'll get the value as 779. Okay, so we have calculated the same problem. So in this class we have gone through the initial basic feasible solution, IBFS. So IBFS is for first, the one is northwest corner method. So in northwest corner method we will get the values as some 1015. In northwest corner method we will get the value as 1015. So in least cost method we will get the value as some 814. So in VAM, Vogel's approximation we will get the value as 779 rupees. Okay, so in all the three methods we are getting the different answers. Okay, so now we have to calculate the minimum cost. So to calculate the minimum cost, compulsory we have to go with the optimality test. So we are having the optimality test, the two methods are there, Modi method and stepping stone method. So this will be taken in the next class. So in the, if you conduct the optimality test means we will get the same result. Whether you have done the IBFS in Northwest, least cost or VAM method, we will get the same answer, same result, whether we have performed in the stepping stone or VAM method. Thank you.